A group of scientists has recently made a discovery so stunning that even the most experienced researchers at CERN, Europe's leading particle physics center, are still trying to comprehend its significance. The announcement, which has been eagerly awaited and shrouded in secrecy for several weeks, concerns a discovery made inside the Large Hadron Collider, LHC, a machine that became legendary after the discovery of the Higgs boson in 2012. However, this time the breakthrough goes far beyond anything known physics has ever encountered. Hidden in trillions of high-energy particle collisions, the anomalies have called into question the very structure of reality as we understand it. Before we continue, don't forget to like and subscribe to our channel so you don't miss any updates. At the heart of this discovery is the identification of a new type of particle, a particle that cannot be classified within the Standard Model, the current theory describing the fundamental forces and particles. This particle, codenamed X17b in CERN working papers, was first spotted in nighttime data analyses. Its appearance was so fleeting and rare that many initially dismissed it as statistical noise. However, repeated experiments with different collision parameters not only confirmed its existence, but also revealed a pattern, a signature indicating interaction with forces beyond the four known ones: gravity, electromagnetism, weak and strong nuclear interactions. The particle exhibited behavior indicating the existence of a fifth fundamental force, an idea that had previously been considered purely theoretical physics. The implications of discovering such a force are enormous. It will rewrite textbooks and overturn decades of theoretical developments. The fifth force could explain some of the deepest mysteries of the universe. Why is gravity so weak compared to other forces? Why does dark matter elude direct detection? How do galaxies hold together despite their lack of observable mass? The X17b particle appears to interact not only with ordinary matter, but also with something invisible, elusive, and possibly fundamental, the basis of dark matter itself. The reaction at CERN following this discovery was a mixture of jubilation and cautious caution. Scientists are trained to follow the truth wherever it leads, but they are also obliged to ensure the integrity of their data and avoid sensationalism. For weeks, teams worked in isolation, double-checking data and trying to reproduce the phenomenon under new conditions while protecting the information from leaks and speculation. The secrecy was not just procedural, but a precautionary measure to ensure that it was not a data glitch, incorrect calibration, or a random cosmic effect. When it became clear that the anomaly was real, the silence was broken, not with an explosion, but with a restrained and controlled announcement that instantly spread around the world and caught the attention of every physicist and technologist familiar with the BAC. What makes the discovery even more frightening is the suggestion that the X17b particle may be just the tip of the iceberg. The team behind the discovery believes they may have stumbled upon a hidden sector of physics, a parallel structure of particles and forces that exists outside the Standard Model but is indirectly connected to ours through rare quantum phenomena. The possibility of such a shadow world existing alongside ours, invisible to the naked eye but detectable through subtle effects in precise particle collisions, has long been suggested in theories such as string theory and supersymmetry. Now it seems that the veil between our reality and this hidden one is beginning to lift. One of the most striking features of the new particle was its decay. Unlike known particles, which decay in predictable cascades, X17b appeared to decay into a series of unpredictable daughter particles, some of which are known, while others have never been observed before. This inconsistency points to either a chaotic internal structure or hidden variables beyond existing models. Even more disturbing, in at least two cases, the particle decayed into something that emitted no energy at all, a complete disappearance that contradicts the laws of energy conservation. Such cases were rare, and scientists avoided public comment, but within CERN, the term zero event began to circulate quietly among laboratories. These events revived interest in a long-dormant topic, the idea of parallel dimensions. The hypothesis that the universe contains more dimensions than the familiar four, 3 spatial and 1 temporal, has been around for a long time, but never before had experimental data hinted so clearly at the possibility of interactions indicating an interdimensional flow. Some theorists have suggested that the disappearing decay products may be crossing over or resonating with another dimension, briefly connecting the two realities. Others believe that the particle may act as a quantum key, a temporary link between our visible world and the hidden substrate that shapes or even controls it. There is also a disturbing idea that X17b could be an unnatural formation. Although the particle only appears during high-energy collisions in laboratory conditions, its strange behavior and stability raise questions about its origin. Could such a particle exist anywhere in the universe? Could it arise naturally under extreme conditions, in neutron stars, black holes, or during the birth of the universe? If so, could it have played a role in the evolution of the cosmos? Some of the more daring voices at CERN even wonder whether this particle was part of the original recipe for the universe, whether it was part of the Big Bang and then disappeared for billions of years until it was recreated artificially. But what really worries some researchers is not the particle itself, but its potential applications. Even a partial understanding of its properties could allow engineers to develop technologies that go beyond the known laws of physics. What was once considered science fiction, reactionless motion, extracting energy from vacuum fluctuations, quantum communication across dimensional boundaries, is beginning to move from the realm of imagination to the realm of theoretical possibility. It is possible that, over time, X17b could be used to create technologies that will change civilization. But with this power comes risk. The particle's instability, its unpredictable decay products, and its apparent connection to forces we barely understand raise the threat of unforeseen consequences. Theoretically, a single mistake could trigger an uncontrollable energy cascade or open a brief portal to conditions hostile to life. In the weeks following the announcement, scientists began developing new detectors specifically designed to study X17b. These devices are much more sensitive than anything used before and are designed to capture all the nuances of the particle's behavior. The challenge is not only to reliably generate the particle, but also to observe it without destroying its fragile structure. Some collisions appear to produce it in the form of entangled pairs, suggesting the possible existence of quantum coherence, an idea that raises new questions about its role in quantum information and non-locality. This discovery has also revived philosophical debates long forgotten in the rigorous world of empirical science. If a hidden sector does indeed exist, perhaps populated by shadow matter or governed by alternative physics, what is our place in this broader picture? Could consciousness somehow be connected to these hidden dimensions? Some fringe scientists think so, while mainstream physicists focus on data reproducibility and mathematical rigor. Science funding organizations have already begun to rethink their priorities. New initiatives are forming, international partnerships are emerging, and old ideas once considered too speculative are being revived. Perhaps the BAC will be modernized again to ramp up production of the X17b. We are on the threshold of a new era of particle physics, not just a continuation of the standard model, but the birth of a new framework that acknowledges that the universe is far stranger, more complex, and more interconnected than we could have imagined. This discovery also serves as a reminder of how little we really know. Despite all the power of human intellect and engineering, nature still holds secrets beneath layers of complexity. The X17b particle is not just a new entry in the catalog, it is a window into a deeper architecture of reality. Through it, scientists are beginning to glimpse a universe that is not passive and mechanistic, but dynamic, perhaps even recursive, with information moving not only forward in time, but also sideways, through as yet unnamed dimensions. If you liked this video, please like and subscribe to our channel. Leave your comments below, and tell us what you think about this chilling discovery by CERN. What effect do you think it will have? Your opinion is important to us. Thank you for watching, and see you next time.